Hello everyone. Today in this video I'm going to explain a really famous algorithm. It's called divide and conquer algorithm, and this algorithm is a sorting algorithm. What I mean by that is that this algorithm is going to sort a list of numbers, as you can see on the left, and from the smallest to the biggest one. Okay, to fully understand this algorithm, you need to have a knowledge in recursion. The first thing we have to do, we need to assume something, okay? And what do we need to assume? Well, we need to assume that this list that we want to sort is divided into two, okay? So basically what we have done is we divided this list into two, just here, and we're going to divide this bit here and that bit there, okay? And the other thing we have to assume as well is that let's just pretend that this bit here is organized or is ordered into it's already ordered, okay, automatically. So we divide it and it's already ordered. So it's going to be from the smallest to the biggest one. So it's going to be 3, 4, 6, and 9. Okay, so that's the first thing we need to assume. Okay, also this so if, for example, we were to say that this list here, these two sublists or subsets of the list A, we're going to call them M1 as mini list 1 and M2. So now that we have this assumption, we need to think about something else. How could we order two lists into a bigger one, okay, which the two a subsets are already ordered? What we're going to do is we need a variable called I, okay, a variable called J, and a variable called Z, okay. And why do we need this? Okay, well, actually, we need this because these variables are going to keep track of something. What are they going to keep track of? Well, these lists are going to keep track of what position we're currently reading from those lists. Okay, so let's just say I right now is pointing here, J right now is pointing here, and then also if I lower this list here, Z is pointing here, okay? And you will understand right now why we need this, okay? This is what we're going to do basically is we're going to read a I and J, okay, the values at those positions, and we're going to see which one is smaller. And the smaller one, we're going to place it in the set position, okay, in the array or list called A. The first thing we have to ask ourselves is which one is smaller, 0 or 3, okay, and the answer is 0. So what we're going to do, we're going to put in the position set, we're going to put 0. And now what's going to happen is I is going to be pointing at 2 and Z is going to point at 5, okay, even though, and now we're going to keep repeating this process. Which one is smaller, the one I is pointing at or the one J is pointing at? And the answer is the one I is pointing at because it's number 2. 2 is smaller than 3. Therefore, we're going to put it in position Z. And then Z is going to be incremented, so is I. We keep repeating this process until, as you will see, um, we have this is going to be finished. And the only problem we are going to find is that one list can be finished before the other one, and we're not going to be able to compare them, and we're going to deal with it now. So if we were to create an pseudocode for this, we will say the following. We will say that, for example, if we were to create a pseudocode, the code for pseudocode, it'd be the following, okay? We're going to create a function called merge, and is going to take the parameters m1, m2, and a, which are arrays. And now we need to create 5 different variables for this, which are going to be a size of m1, which is going to be m1.length, size of m2, which is going to be m2.length, I is equal to 0, j is equal to 0, and z is equal to 0. We need a while loop that is going to ask which one is bigger, the one I is pointing at or the one j is pointing at. This while loop is going to say once none of those lists are finished, keep repeating the same process. So we need a while loop here. While I is less than the size of the first array and j is less than the size of the second array. Now, in this while loop, what are we going to do? Well, we need to check which one is smaller, the one I is pointing at or the one j is pointing at. So, basically, we're going to have an if statement, which is going to say if the element I in list m1 is smaller or equal to the element j in list m2, a, z, because z is pointing at the location of a, is equal to m1 element I. Then also we need to increment I so that now it's looking to the next position. What I mean by increment is that once we put the number 5 here, so if we were to keep doing this process, we would have to put the 5 here, and then I would be incremented to be looking at the next element, and set would be incremented to be looking at the next element. So that's what we're going to do. We're going to say set plus plus as well, okay? Else, and we'll say, well, element set in A is equal to element j in M2. And as well, we have to increment j plus plus and set plus plus. We have a little problem, and the little problem is the one where j is still here and I is finished. So there, this while loop here is never going to be finished. Well, we can deal with two little while loops that if one of them is finished, so we can say while I is less than the size of the list m1, az is equal to mi, and we have to increment again z plus plus and I plus plus. We need another while loop here that is going to say the exact opposite. So now to just explain what I did is we have a while loop that says while none of those lists is finished, then we want to ask our question which one is bigger and which one is smaller, and the smaller put it in the big array. And when that's finished, so let's just assume this list here is finished, when one of these while loops is going to be executed, the one that is not finished yet. So if the list m1 is finished, this thing will never get executed, and this one will, and therefore that's going to be completed. It's going to fill the big array with the rest of the digits, because we just know already that the sublist is ordered. So now we know that this function is going to order an array from the smallest to the biggest one, taking two smaller arrays that are already ordered. We know that these two lists here are never going to be ordered, which means that these lists are actually going to be written as they were before. So basically, if we were to go back and say, okay, this list here, we're going to divide this list into two little sublists. The little trick we could do right now is, okay, how about if we divide these two sublists into two other ones? And what we're basically doing, we're just breaking down the problem. Now we have four sublists, and could we just do the merge equation right now? Well, we can't, because we still have a problem. This list here, 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 and here are not ordered. We can just divide this little sublist into two to make double the amount of subsets. If we were to get all these numbers here sorted, so basically these two ones will be 3 and 9, and that 4 and 6. This one will be returned as it is. This one will be returned as 3, 9, and then we could keep doing this until we had like a ordered list. What we've done right now is we've broken down a problem, a very big problem, into very small steps, and we're going to organize the entire list by just making little problems. Okay, so the first thing we have to ask ourselves is, what have we done? Okay, And for that, we're going to create a function, and we're going to call it divide and conquer. This function is going to need a parameter, and this parameter is going to be called size, S for size, and it's going to be a.length. It's going to be the length of the first list. If size is less than 2, so if we've gotten to the point where the list, all the little lists are just one item long or one item big, we'll have to say return. Now, if you remember what we did at the very beginning, we created a line here and we said that's going to be the middle point. We're going to create a variable called middle, and that is going to be size divided by 2. And m1, which is going to be an array, that is going to be the size middle. And also we need to create an array called m2, is going to be middle minus 1. So these two for loops are going to fill two little arrays of half the items of each, okay? We're going to keep repeating the process. So now what we can do is we can call again this function, and we're going to say m1 and also divide and conquer m2. We have to call the function we created early on, which it was called merged. And remember, it took two parameters, which is going to be m1, m2, and a. We have this list here that is going to say, okay, this function is going to create two little lists. So it's going to go and it's going to say, okay, let's just create one list and let's create another one now. And now we have created two sublists. And remember, we just here we created one list and we created another list here. And now the cursor, as you can see, is here. So what is going to happen? Well, what's going to happen is that this function is going to call m1. Remember, m1 is this one, and it's going to create these two sublists again. And then it's going to call itself, and it's going to go up again, and it's going to create two sublists. Now we have two sublists, and what's the next thing is going to happen? It's going to create these ones here, and then it's going to go back, because now return s, which is the size, is less than 2. So it's going to return to the main one, and it's going to create those ones, and then it's going to up all the way up, and it's going to create the other ones until s is less than 2. So it's going to return. So now it's going back to merge m1 and m2. So for example, this one is m1 and m2, and it's going to merge them in an ordered way. Then it's going to organize these ones, and it's going to say 0 and 2. Now that we're back here, we're going to do the exact same. Now m1 and m2 are this one here and this one here, and it's going to return them in an ordered way. And it's going to repeat the process for this one here. So it's going to put them in ordered way. At the very end, we're going to end up with two lists, and the last call function is going to be merged with the two original functions, going to be m2 and m1. And again, it's going to order the big list